Hello, it's Valentine from Simplistic, and today we're going to take a look at a problem where we have a reaction. The reaction is carbon monoxide plus 2H2O gives us CH3OH. It is at equilibrium, and what's interesting is that the reaction was carried out with an initial concentration that is given to you for carbon monoxide and H2, and the equilibrium concentration of CH3OH is given as 0.11 molar. And we have to find the equilibrium constant at this temperature. So one thing to note out here, initial concentration is not the same as equilibrium concentration, okay? So what we need to do is we need to construct an ice table, okay? So just as a refresher, an ice table maps the initial, the change, and the equilibrium in a reaction. Okay, so we have the initial, change, equilibrium. That's where the ice comes from. And so we're just going to go ahead and write this reaction a little bigger, giving us a little space. I'm not going to worry about the phases. They're all in the same phase. So I'm just going to write carbon monoxide plus 2H2 gives us CH3OH. All right, so once we have that, I'm going to write down what we have initially. We have 0.27 molar carbon monoxide. So I'll put the 0.27 out there. We have 0.49 molar H2. And because it's at its initial, that means the reaction just began, so there should be no product. So therefore that should be 0.00 molar. And then at the change, so when the reaction reaches equilibrium, the change is going to be carbon monoxide. Let's call the change X. So carbon monoxide is going to go down by X amount. So I'm going to put minus X. And then because for every mole of carbon monoxide, 2 moles of hydrogen react. So therefore, proportionally, the hydrogen should go down by negative 2X. And then for every mole of carbon monoxide, 1 mole of CH3OH is produced. Therefore, we're going to have plus X for the CH3OH. All right, so once we have that, then at equilibrium, it's simply going to be the initial plus the change, which is going to give us what's the equilibrium quantities. So I'm going to just draw a line out there, and then I'm going to get 0.27 minus X for carbon monoxide, 0.49 minus 2X for 2H2, and then 0.00 plus X for CH3OH. All right, so once we have that, now in the problem it tells us that at equilibrium, the concentration of CH3OH is 0.11 molar. And so we can say that, hey, this entire amount is equal to 0.11 molar. So X is equal to 0.11 molar. So now we can just plug in the value of X in these two to get the quantities. So when we plug in the value of X out here, we get 0.16 molar. We plug in the value of X out here. This one reduces to 0.27 molar. And of course, we know what that is. So at this point in time, let's write the equilibrium expression for this reaction. So that's Kc is equal to CH3OH over CO times H2 raised to the power of 2. And now we'll just plug in the values of each of these equilibrium concentrations. So CH3OH is 0.11 molar, so that's 0.11. The whole thing is divided by 0.16 for CO times 0.27 for H2 raised to the power of 2. And if you simplify this, you get 9.4. And that is your equilibrium constant for this reaction at whatever temperature this reaction is carried out. I hope that made sense. Thank you for watching.